Hello, my name is Brent Taylor, and I want to talk about character movement in Unity. Don't run away just yet. I know you've probably seen this tutorial 1,000 times, but I promise I've got something interesting to talk about. We're really going to talk about two different ways to make a character move and cover some of the pros and cons. If you want to follow along or test this out for yourself, I have a link to the project down in the doobly-doo. Next, we need to talk about Unity's default input system. Unity has two essential types of input: axis and button presses. Think of an axis as a sliding value between -1 and 1. A joystick on a gamepad when idle or centered would report a 0 on this axis. The further you move that joystick to the left, the closer it will get to -1. The further you move that joystick to the right, the closer it gets to 1. An input axis is fantastic for input from gamepads, joysticks, flight pedals, and that sort of thing. However, it's not ideal for getting input from a keyboard or mouse. A button press or button down event is far more simple. Either the button has been pressed, or it hasn't. In a project that allows for both mouse and keyboard input as well as gamepad support, you'll need a combination of these tools. However, for this example, we just need button presses. Unfortunately, Unity defaults to using an axis system for its input. Let's change that. To do that, go to Edit, Project Settings, and you want to go to the Input Manager. Now, by default, you have a certain number of inputs defined by Unity. The default is usually 18 inputs. In our case, we need to add both a left and right input, so we need to increase this to 20. Notice how two more pop up at the bottom of the list. Let's change the first one. Let's rename it to left. And the key we want pressed is going to be a positive button. And let's make that the A key, using WASD for movement. And now we need to do the second. Let's change that and rename it from cancel to right. And the positive button needs to be D. Go ahead and click the X in the corner to exit out. Let's start by exploring our scene a little bit. Our scene consists of 4 main objects. We have our main camera. We have a character object, which at the moment is just a sprite. We have the background scenery. And then we have this keyboard input widget that I've rigged up. All this does is, at runtime, it displays what button is currently being pressed for movement. Next, we need to set up our character for movement. We need to add a rigid body 2D component to it. So let's click on our character. In the right-hand panel, click Add Component. We're looking for rigid body 2D. Once added, we need to change the body type from dynamic to kinematic. Stop, wait, rigid body 2D, kinematic? I need to do an entire video on Unity's physics system as it's a big topic, but here's what you need to know for now. A rigid body in Unity is a component that will tie an object to the physics system. If you want something to interact with or be affected by physics, it needs to have a rigid body component. But what about this kinematic thing? Rigid bodies have 3 body types. Static bodies are rigid structures that don't move and can't be moved. They are used for things such as walls or terrain features that other physics objects can walk on or run into. Dynamic bodies can move and can be moved by other physics objects. They can have physics forces applied to them and receive forces when other physics objects run into them. As an example, the cheese wheels in Skyrim are dynamic bodies. Kinematic bodies only interact with dynamic bodies and do not have forces applied to them. They are a lot like a marionette and tend to be used for characters where you want to interact with the physics engine, but not actually be controlled by it. Kinematic bodies are controlled strictly through code, often called character controllers. Now let's talk about the math, the algorithm we're going to use to move the character. The first thing we need to define is our speed, also known as velocity. The standard unit in most physics engines is a meter, so 1 unit is equal to 1 meter. We need to determine how many meters per second we want our character to move. Let's pick a round number of 10 meters per second to start with. To determine our actual velocity, and to keep the game frame rate independent, we need to also multiply our speed by time.delta time. With our speed defined, let's lay out the algorithm. If the player pushes the left button, we need to subtract our velocity from the current position on the x-axis. On the other hand, if the player pushes the right button, we need to add our velocity to the current position on the x-axis. With our algorithm out of the way, let's get this character moving. First, let's create the character controller. Go to Scripts in the Project panel, right-click, and click Create, C# script. We'll call it Player Controller. Once that's created and Unity is done compiling, we're going to drag it over to our character in the scene hierarchy. With that added, if we click on Character, you'll see it's been added as a component in the inspector. Go ahead and double-click on Player Controller in the Project panel. First, let's add our meters per second field to the inspector. And we're going to set it to a default of 10. We'll also need a reference to the rigid body associated with the player controller. In the start event, we'll also need to assign our rigid body to our reference. We do that using something called getComponent. Next, we need to pull for input. Now, input in Unity is always pulled during the update event, but movement is done on the fixed update event. So somehow we need to give information from one event and pass it to another. We're going to do that with a couple of Boolean variables. Let's clean that up a little bit. And let's actually pull for that input here. Now, this is actually really simple. All we're doing here is polling the input system asking, is the left or right button pressed? If so, return the result into those two Boolean values, move left and move right. With our input polled and cached, we can move on to actually moving the character. Now, in Unity, anytime you're interacting with the physics engine, it has to be done in an event called fixed update. So let's start there. This is where we start with our algorithm. So first, we need to decide our velocity. And that was equal to meters per second times time.delta time. We're also going to need to know our current position. Now the fun part, we get to actually decide what we do based on player input. So if the player has held the left button down, we need to subtract velocity from their current position on the x-axis. So let's do that. If move left is true, we need to subtract velocity from the position. On the other hand, if move right has been pressed, we need to add velocity to the current position. And finally, we need to actually set our new position. Now this happens through a method on the rigid body itself. Whenever you're using a kinematic controller or a kinematic body, you always need to move using a method called movePosition. Save it out. Let's go back to Unity. Let it compile. This will take a moment. And let's see if it works. right. Holding left, holding right, it works. Congratulations, our character moves. But there's a bit of a problem. Let's run that again. Our character moves left and right just fine. The problem occurs when the player holds both buttons down. Our character simply doesn't move. What if our player is moving one direction and simply wants to move in another direction very quickly, and they're just a little slow letting up on the other button? You get this very perceptible lag, or stop, in movement. It doesn't come off as particularly responsive movement. Now there's a way of solving this problem using a method called finite state machines. So what is a finite state machine? A finite state machine is a collection of states and transitions between states that can only have a single active state at a time. A state machine moves from one state to another when some form of input or event triggers a transition. Here's an example of a finite state machine. It's a fairly common flow of just about any video game. In this case, it would start in the state called game running. Should the user press the pause button, the state machine would transition to the game paused state. Note the pattern. A finite state machine waits in an active state for some sort of input or event that triggers a transition, then transitions to the new state. Let's take that information and apply it to our movement problem. First, we're going to need three states: an idle state, a moving left state, and a moving right state. If a finite state machine can only be in a single state at a time, it'll be impossible to be simultaneously moving both left and right. Let's add our first transition. If we're in the idle state and the left button is pressed, we want to transition to the moving left state. Let's also define our return transition. If we're in the moving left state and the left button is released, we want to transition to the idle state. Here's where the magic happens. Let's add our transition to the moving right state. If we're in the moving left state and the right button is pressed, we want to transition to the moving right state. Note that we don't care if the left button is still pressed or if it's been released. We just immediately transition to the moving right state and we're no longer watching for the left button to be released. This completely solves our initial problem. Let's finish off our state machine and add the rest of our transitions. If we're in the idle state and the right button is pressed, we want to transition to the moving right state. If we're in the moving right state and the right button is released, we want to transition back to the idle state. Lastly, if we're in the moving right state and the left button is pressed, we want to transition to the moving left state. So how do we use finite state machines in Unity? This is where Bolt comes in. Bolt is a visual scripting system for Unity that also provides a visual approach to state machines. It's also a free extension on the Unity Asset Store. Sign in with your Unity account, add Bolt to your assets, and swap back to Unity. Once you're back into Unity, we need to download and actually import it into the project. Go ahead and go to Window at the top and select Package Manager. This will bring up a new window. In the top left of this window, you're going to have a drop-down that says something like Unity Registry or In Project. You want to select My Assets. In the list on the left-hand side, you should see Bolt. If it's not already downloaded, you will want to click this big download button in the bottom right-hand corner, and then import it into your project. This will take a few minutes. Once Bolt is imported, you'll have to actually install it. Now, it comes with a full wizard for installation. You can find it at the top under Tools, Install Bolt. It'll unpackage it and ask you to import a bunch of stuff. Go ahead and just click Import. This may take a few minutes. Once it's unpacked, the wizard will start up. Go ahead and just click Next. It gives you an option here for how you want to see data represented. If you are familiar with programming, you're probably going to want the programming naming. It's more familiar to people who know C#. It'll use the same sort of naming conventions that most of your namespaces, objects, classes, libraries, and so on use. Otherwise, use the human naming. In our case, being as we're only using Bolt for state machines rather than as a visual programming language, we're going to select programmer naming. Here you get to choose all the assemblies and libraries that we want Bolt to have access to. This should be fine by default. Go ahead and scroll down to the bottom and just click Next. And lastly, this is asking you how you want to associate naming and variables. Honestly, I would just leave this as it is and click Next. Or, I'm sorry, click Generate. Again, this will take a few minutes. And lastly, when it's done actually importing all those libraries and such, go ahead and just click Close. With Bolt installed, let's add our finite state machine. Go ahead and click on our character in the hierarchy view. On the right-hand side in the inspector, scroll down and click Add Component. Go to Bolt and select State Machine. Now there's two ways of adding a state machine to an object. You can either embed the state machine on the object itself, or we can save it as a file to be used on other objects. In this case, we're going to make it an embedded state machine. Give it a title. In our case, we'll call it Movement FSM. Summary, we'll just leave blank, and we'll click Edit Graph to, well, edit the graph. Let's talk a little bit about navigation. So, to see all of the controls at your disposal when editing a scene graph, click Full Screen at the very top right-hand corner of this little graph area. This brings up a panel on the left-hand side where you'll be doing most of your editing of little details on the finite state machine. To navigate around, you will middle-click to drag. You can use your scroll wheel to zoom in and out, which will be very useful. Right-click allows you to add nodes, and you can double-click to navigate into nodes. Nodes have additional details within them. At the very top here of this graph window, you'll see a couple of things. You'll see zoom, you'll see what node you're currently in, and if you click on this multicolored little icon here, it'll bring you back to the overall overview state. Let's start by adding our initial three states: idle, moving left, and moving right. We'll take our initial starting state here, and we'll rename it to idle. In the top left corner of the graph inspector, we can rename it here. We can add other flow states by right-clicking in the empty space and clicking Create Flow State. Do this twice. Arrange them in sort of a triangle, giving plenty of space in between. We'll name this flow state on the left-hand side, moving left, and we'll name this flow state on the right-hand side, moving right. You'll notice how our idle state is currently green. If you right-click on it and select Toggle Start, it turns gray again. Your green state is the initial starting state of a scene graph. So make sure it's green. Toggle it on. Flow states in Bolt can have a number of events assigned to them. Let's double-click on idle to inspect this node. You'll note we have three events: an on-enter state event, an update event, and on-exit state. These are triggered whenever these events happen. In our case, we only want the on-enter state. So what we'll do is we will lasso select the bottom two, right-click, and delete selection. In the top left corner of the graph view, select character again. And we'll want to do the same thing for the other two nodes. With our state events cleaned up, let's start adding our transitions. Our first transition, when the left button has been pressed, is a transition between the idle state and the moving left state. So let's add that. To add a transition, right-click on the starting node, click Make Transition, and simply click on the destination. This gives a nice, easy visual indication of what's going on. Let's add the rest of our events, or the rest of our transitions. So when the left button is released, we want to go back to the idle state. So let's add that transition. And we need the same transitions going to the right. And lastly, we need a transition between moving left and moving right when buttons are released. We now have a nice visual of our state machine, but at the moment we have no way of polling the state machine for the current state, nor do we have a way of triggering transitions. Let's solve the first problem. In our playercontroller.cs file, we'll add an enumeration of all of our current possible states: idle, moving left, and moving right. Save the file and return to Unity in our finite state machine. we want to set a variable that we can access from our code. This is done through the Graph Inspector on the left-hand side. Click on the Object tab. This is where we set and access variables on our current object from our state machine. Let's create a new variable. Give it a name such as current state, and click the little plus button. This will create the variable and give us the ability to edit it. Set the type to playerController.states and its value to idle. With our variable created, we now need to set it when we enter a new state. We'll do so in the onEnterState event for each state. Let's start with our idle state. Go ahead and double-click to edit. Now, Bolt is a visual programming language. It represents programming logic through a flow of nodes, and all node flows start with some sort of event, in our case, the onEnterState. To add code to this sort of flow, you just drag from one input or output to another. So in our case, we're trying to set a variable, our current state, to whatever state we're currently in. We're currently in the idle state, so let's set that. Drag from your initial onEnterState, and we want to set a variable. At the bottom of the list here, you'll see variables. Click it. We want to set an object variable, and we want to set the current state. Now, we also need to set it to a particular enumeration. In our case, we want to set it to idle, much like we did before. So, take the input, this little green node at the bottom here, and drag off of it. Type in player controller, because that is where our enumeration is, dot states. And we're looking for the literal. Now, if for some reason that doesn't show up in the list when you type that out, it means that Bolt needs to reinitialize itself. Go ahead and go to Tools, Bolt, and click Build Unit Options. We now need to do this to the other two states. The easiest way to do this is to hold Shift and click on your first node, and then click on your second one. Hit Control-C to copy. At the top left of our scene graph here, click Character. And let's start editing our moving left state. Control-V to paste it in, wire it up, and we'll change this to moving left. Again, click Character at the top left, go to moving right, Control-V to paste, and wire it up. Set it to moving right. With our current state variable wired up in Bolt, we need to get access to it in our code. Bolt provides a simple way to access it. Open up our playerController.cs file. First, we need to give ourselves access to the Bolt namespace. Next, we're going to add a new property with a getAccessor. We'll call this property currentState, and it will return a value from our state's enumeration. Bolt provides a simple way to get the value of variables associated with a given object in the scene. We simply need to provide it with the name of the variable we want access to. Now we need a way to tie our events to code and provide a way to trigger those events. Hop back over to our playerController.cs file. Much like our states, we'll create our events as an enumeration. We'll have 4 events: left down, left up, right down, and right up. And we'll need a way to trigger these events in our state machine. We'll create a new method on our character controller called triggerEvent. It will take the event to trigger as its only argument. Bolt itself gives us a handy way to trigger events on the state machine associated with the current object. We just need to tell it what event to trigger. We no longer need to cache the values of our player input and instead can pull our input system and fire events if necessary. We start by checking for button down events on both our left and right buttons. If either of them are pressed, we trigger our left or right down events. We repeat the process when checking for button up events. Next, we have our fixed update. We no longer need to check for the cached values of our input. We just need to check our current state. We'll do this with a switch statement. Seeing as a finite state machine can only be in a single state at a time, we simply need to jump to the proper label based on the current state. Of special note is our idle state. If we are currently idle, we simply return from the fixed update event rather than moving our position to the same spot. One last refactoring is our cached values, move left and move right. They can safely be removed. Save your work and hop back over to Unity. Time to see our hard work finally pay off. With our events defined and a way to actually trigger them from code, we need a way to listen for them in our state machine. We've defined our transitions, but now it's time to actually rig them up. Let's edit our first one. This transition is triggered whenever the left button down is pressed if we're in the idle event. Let's double-click to edit. We're looking for the left button down event, or left down. It's in our player controller. So right-click and add a unit. Look for player controller dot event. And we are looking for the left down event. Now, we need something special. What Bolt is going to use here is something called a custom event, a type of event it's listening for internally. Go ahead and right-click and go to Events. Scroll down to Custom Event. This is where most of the magic happens, but we need to rig these two nodes together. For type safety reasons, we can't just rig up a enumeration directly to an event. We need to convert it into a string first. So, go ahead and drag from our events and type in toString. We're looking for object toString, and we can rig that up directly. And lastly, once this event is found, we need it to actually trigger the internal event. Just simply drag it over, and we're good to go. But we now need to do this for 5 other events. So let's lasso select all of them and hit Control-C to copy. On the top left, click Character, and we're back at the overview. You'll note the icon has changed to a little sorcerer's hat. That is an indication that we're using a custom event. Let's edit the event should the left button be released. Control-V to paste. Let's drag it over. Rig it up, but we need to change the event. Left up. Again, hit Character at the top left of the graph view. And we're going to do the same thing to the right states. So our first state here is we are looking for the right down event. Control-V to paste it in. Rig it up and change the event. Let's do the same for the remaining events. We're listening for the right down button. And lastly, the left down button. We finally have all our events rigged up. I've taken a moment to move our state graph into the bottom of our window here so that while we're playing our game, you can see what our state machine is actually doing. It allows us to visualize what's going on, and it's a great way of debugging problems when they arise. Now, let's actually play our game and watch what happens. We started our game up, and we're currently in the idle state. I'll hit the left key, and you'll note we're moving left. If I hit the right key, we start moving right. You can see exactly what's going on in the state machine at any given time, and yes, we can move between all the states. Note that if you're moving one direction and hit to another direction, it immediately transitions. Much more responsive movement. No more stops, sudden stops, and very predictable, easy to work with movement. As complicated as this surely seems to set up, I can promise it's worth the complexity. As your state machines grow in size and scope, this method actually serves to dramatically reduce that complexity. Do this a few times and the setup becomes second nature, and it's quick to put together. Take the time to start thinking about behaviors in games as a collection of states, and you'll start to see incredible uses for state machines everywhere. They can and will save you time and reduce the complexity of your code. Also, while this video is primarily just an excuse to give an introductory lesson on finite state machines, I would encourage you to always spend the extra effort to make sure your player movement is fluid and responsive. If you enjoyed this video or found it helpful, there's a lot more to come. I'll be covering game design and development in both Unity and GameMaker Studio. If you'd like to see more, please click that like button and bang the bell. I'm a new content creator, and you'd be surprised just how much it helps the little guys like me. If there's anything you'd like to see covered, or have any suggestions or criticisms, please leave a comment down below. I do read them all. Until next time, I wish you the best of luck in all of your game development endeavors. Please take care.